Huh? Are we rolling? Ja, sweet. Ja. Jeg skal ta dette på engelsk. Regner med det er ikke problematisk. Yeah. So I'm going to give you some really good tips about how to lose money with DynamoDB, which is obviously kind of database. I'm going to run through this through the story of how this happened and why it happened really, and why it's not such a bad thing in the end. Let's try. Oh, there. Okay, good. So the origin of the story is it's happened with a hobby project, and a lot of people here won't be surprised to find out that it was a hobby project to do with beer. So to give you some necessary context about this hobby project, some things you have to know. Untapped, probably most people have maybe heard of it, but it's a beer journaling app, like a social media thing where you can check in the beers that you drink, give them a rating, take a photo, and you can go back and see it again later, how much you like that beer, and yeah. The other part of this is that the hobby project I'm talking about is a beer festival beer list app that shows you all of the beers at a beer festival, and it gives you lots of metadata about them, like the kind of general category they're in, the kind of beer style, an average rating for other users of the app at the festival, average rating from Untapped, and it lets you sort, filter, and search. It's a progressive web app, so it's really just a web page. And it's been previously featured in another talk at RevolverConf. Okay, so the important thing you have to know about people who use Untapped is that the really important number, like followers for people who are a little bit too interested in Twitter, followers there, the clout number is your number of unique check-ins. That's the number of unique beers that you've had. And that drives the want to avoid drinking the same beer twice. That's unproductive. So part of the feature of this beer festival beer list app is that it will integrate with your Untapped account, and it will allow you to load in your unique check-ins, so that you get a little marking on each of the beers which you have previously drunk, so you can avoid those like the plague. It shows that little star in the corner. Now, the technical part behind this is a little bit challenging because Untapped's API was written when Untapped was first written, which is about 14 years ago, and it hasn't been updated since then. At that time, they were pretty worried about people stealing their data, and so the allowances they gave to people who they gave API keys were very restrictive, as shown here with your rate limit is 100 calls per user per hour. And in addition to that, because it hasn't been updated in about 12 years, there's no really good endpoint, no way to cross-check a list of beers and see which beers the user that you're calling for has drunk. So you've got a list of beers that you want to check, which one of these the user has checked in before. The only way to do that is to read out every single unique check-in the user has made. So there is an endpoint for reading out unique check-ins, and that's just the way that you have to do it. The other part of that is that endpoint, it returns a maximum page size of 50. So if you do the math there, that's a maximum of 5,000 unique check-ins that you can read out per hour. And this didn't used to be a problem. When I first made that beer list app and that Untapped integration, there was no one complaining that they couldn't read out all of their beers. Untapped wasn't that old. Now Untapped is getting on a little bit, and people have had accounts for a good long while and have continued to drink beer, and now it's very common for people who are using that app to have over 5,000 check-ins. Something a few years ago had to change to make it possible to more easily read in your unique check-ins. The solution to that was I would make another service. I ended up calling it Unticked. I chose a bunch of AWS technology to do that, pretty much because I had had brief experience with it before, and it had always been free. And this is a hobby project, and one of the very important things is that it should be as cheap as possible. That's how I ended up using DynamoDB for it. The other thing is that I decided to make it a separate service because I have other hobby projects that involve beer lists that also would benefit from being able to easily read out which beers a user has checked in before without going to the untapped API and reading out all of their unique check-ins. So it would be pretty simple. Ideally, it would have an endpoint which returned all of the users' check-ins, simplified, so it only gives you the rating and the timestamp and the beer and the check-in ID. And it would have an endpoint where you could check if a user has checked in a beer ID. You give it the user ID, the beer ID returns the check-in if the user has checked in, or a 404 if they haven't. So the plan to implement this was I would store the check-in histories in my database. I would do some scheduled updating, so I'd use the AWS thing which runs a Lambda on a schedule to read that user's unique check-ins once an hour and add any new unique check-ins. And just for context here, the scale we're talking around is about 2,000 to 3,000 users. I do this for a few different beer festivals, and 500 to 10,000 check-ins is normal for untapped users at those festivals. But there are outliers. I know of some that have over 40,000, and they have to be supported too. Enter DynamoDB. Hooray. So again, the reasoning behind DynamoDB for this project was it was supposed to be as cheap as possible, ideally free. Ideally, this entire thing would be completely free, perpetually. It would be in the free tier of Amazon's usage. And acceptable to me was up to around $5 a month, but that's the point at which you could just run an EC2 instance with a relational database on it, which would be better, except you have to manage the infrastructure yourself. If you wanted to run a fully managed relational database on AWS infrastructure, I think it costs a lot more than that. I think we have one for like $35 a month at my job. But, you know, everything else I had done on DynamoDB previously had been free, so this should be the same, shouldn't it? I mean, so it's AWS native, it's proprietary, it runs in the cloud only, you cannot run it locally. It's fully managed. So there's no test, you can't download DynamoDB as software and run it on your local machine.
You can.
You can?
There is a container you can run.
Really? Okay, well, I didn't know about that. As far as I know, you can't see the source code though. And it can be, if you use it correctly, it can be perpetually free to a surprising amount of usage. It is a key value database. It's got keys and values. What else do you need? So, this is something that you would, this is what something that you would store in DynamoDB looks like. This is let's call it a row. It looks like a JSON object or a document. And if you go to the DynamoDB website, to Amazon's marketing about DynamoDB, it will not appear anywhere on that page, on that landing page, the words key value or KV. It does not market itself as a key value database. It markets itself as a NoSQL database. And it markets itself as being able to store things like this. So people could be forgiven for thinking that it's something more adjacent to MongoDB, some kind of document database. Remember that, because that becomes important. All right, so my use case this is my very super optimistic first naive implementation. Without going too deep into, without me going too deep into the documentation about how DynamoDB ideally should work, I just stored some objects, but it is actually stored as binary data, the whole object, and I think you can query into objects like that as well. Yeah, so I did implement it. It worked. Made the first version. I released it a couple of weeks before a beer festival. I sent it to some friends. People started using it. And I immediately started running into some slight issues. People reporting that all of their check-ins weren't getting loaded, that there were check-ins missing from unique check-ins that should have been marked off as drunk, were horribly incorrectly not marked off as drunk. If you optimize it to the highest degree that you can, it's still 10,000 check-ins is around 500 kilobytes. And there were people with 40,000. So this wasn't going to work. Had to start again. So this time, much better idea. I would do a check-ins table where every row was a single check-in. Have the check-in ID as the key, and then on the row I'd have the user ID, the beer ID, the timestamp, the rating. Same information, but spread over one check-in per row. Each row would be super tiny, so I wouldn't meet any size constraints. Only problem, I did that and I released it. People started using it. Only problem was the bill started going up. Yeah. Problems were solved with missing check-ins, but for some reason, only maybe 5% of the users that would use this at the beer festival were using it. It's just my friends. It's 2 weeks before the beer festival, and up until now, it's really not a whole lot of usage, but still, the bill is increasing at an alarming rate. This is a dramatic reconstruction here. I don't have but yeah. It looked a bit like that. Up until this point, I had not really been considering, it had been in the back of my mind that this could cost a couple of dollars, but I had not really been considering the fact that what I was doing could be beyond the free tier. And I've just been doing what was easiest for me rather than optimizing for cost. And another little fun thing that was happening was that sometimes people just couldn't load their check-ins. They were just getting weird errors. So yeah, it was time to find out sort of why this was happening. It's surprisingly not straightforward to find out how DynamoDB charges. It's very easy to go in circles, and it's very easy to find lots of text. Not so easy to find actual numbers. But you get there in the end. You will get there in the end. Here's some. Aha, so we have $1.25 per million write request units, $0.25 per million read request units. What is a read request unit? What is a write request unit? Well, not defined there, but they are one read request unit per row or kilobyte, and the same thing for write request units. So if you read out one row of 400 kilobytes, that's 400 read request units. If you read out 400 rows of 15 bytes, that is 400 read request units. If you read out 400 rows of 400 kilobytes, that is 160,000 read request units. So, how were we finding those rows? This is what the data looked like for the check-ins. So remember the use cases. We need to find if a user has drunk a specific beer, and we have to find all of a user's unique check-ins. So the primary key here is the check-in ID. I don't have that if I'm looking for, has a user drunk this beer before? So we have to scan. And that means we have to read through every row in the database until we reach the row which matches the filter. And it's worse if you need to read every one of a beer's check-ins, because that means you have to read through every row of the database, full stop. You just can't be sure until you get to the end that you've got everything. Let's do some math. So we've got about 100 plus thousand check-ins stored at the moment. About 800 active users there'll be in a week. So that's 100,000 times 800, that's 80 million. Okay. It was 25 cents per 25 cents per million requests. So 80 million divided by a million times 25 cents. It's $20 to read everyone's check-ins once. I was going to poll. It was going to be a lot more than $20. So, in addition to this, some people just couldn't read out their check-ins at all. It turns out not only is it very expensive to do it that way, but AWS has a quota of how many read request units you can use, the amount of throughput that you can have. And scanning through a row with 100,000, scanning through a table with 100,000 rows in it, not really great. So sometimes it would just be like, no, you can't have a response to that request. It would just give you an exception, because the scans were reading 100,000 rows right off. This is the point at which I actually have to learn how the database works. And the most important thing is to go to that second or third page underneath the landing page for DynamoDB and understand this is a key value database. So it has a thing called partition keys. Those, if you're using Redis, that's the key for the thing. In Redis, the concept is quite simple. You've got a key and you've got the value. DynamoDB, the key is built into the object or the row. So here, I've just got some dummy data, and I have the simplest possible use case. I've got a list of stuff, and each of the stuff has an ID, and that's the partition key. Assuming that you know what those IDs else are from somewhere else, you can go straight to that row and get that row out. In addition to partition keys, you have a thing called a sort key. And this is sort of like having a composite key in a relational database. You can have the key for that row becomes the combination of the partition key and the sort key. As the name suggests, it also forms the shape of, it forms the order in which that data is stored, which can help optimize when you're reading out based on how that data is sorted. This specific data set is a bit dumb. You shouldn't probably use a sort key for the beer style here, because it would mean that each brewery could only have one beer of each style. But it's an example. Yeah. Oh yes, I've got the sort key in green. Yeah. So if we go back to my use case, the solution then is it fits really well with the partition key and sort key. Had I just done a little bit of due diligence beforehand, I could make the user ID the partition key and the beer ID the sort key. It solves both use cases, because if you're just looking to get out the beer, to check if a user has checked in a specific beer, you know the user's ID, you know the user's beer, the beer ID, you can go straight to that row. That's one read request unit. If you want to get all of the user's check-ins out, you just read all of the rows with that partition key out, and it uses the same amount of read request units as the user has check-ins. The minimum amount for this structure. Works. And it has been working. It's been running for a couple of years, and it's got, yeah, as I said, 2,000 to 3,000 users total, and the bill is within my budget. It isn't free, but it is under $2 a month. But there's more. It's not the only time I've lost money with DynamoDB. I work for a company called Nordic Beverage Solutions. We do alcohol logistics. We use DynamoDB for a tiny little sliver of our services. When we receive and send messages to external third parties like Vinmonopolet and Asko. Like when Vinmonopolet send us an order that comes as a message, it gets archived in a DynamoDB database, and then it goes and gets processed by our main system. So we've got two use cases that we need to satisfy for this specific service. We need to be able to read out individual messages by their key, and we need to be able to read all of the messages since a certain timestamp. This is a little example of what the data looks like. We've got a bunch of messages and their keys, and their types, and we've got the timestamp there. And it is, and still is, keyed by the message key. The problem is that there's no obvious, using the information that I've given you so far, there's no obvious solution which satisfies both use cases, where you can both easily read out a specific message with a specific key and read all of the most recent messages since a certain timestamp without scanning. And in the first implementation, the solution was just to scan and to accept it. And the scale of this was a lot smaller. So it was, well, in the start, we started from 0. So it just wasn't a problem at the start. It's like 100 read request units to do a scan. But we grew pretty quickly, and now we have hundreds of thousands of messages archived, and doing a scan would cost hundreds of thousands of read request units, and so something had to change. This is where the final piece of the puzzle comes in. Secondary indexes. This allows us to specify a secondary partition key and sort key over that same data set. So using that data set that I showed you just now, again, the solution, once you know the mechanism, the solution becomes pretty easy. Just set a secondary partition key on the source and the sort key on the timestamp. And since that's sorted, we can do a query which reads the most recent messages by timestamp, and it will only use the amount of read request units of the amount of messages that it reads, because it just goes down the list and stops when the filter stops being satisfied. And that too has worked really even better than the beer list app use case. This is as of March 2024. It costs a total of 83 cents to do that. Again, we have about 450,000 messages. That's 0.5% of our AWS spend. The Lambda part of that service is free. So that entire section of services in our infrastructure costs a total of 83 cents plus tax. And compare that to our Postgres server, which I love a lot more, but it costs us 20% of our AWS spend. It can do a lot more though. Fair enough. So DynamoDB, is it good? Do I recommend it? Oh, it took a little while. It's good if you satisfy a few things. If you are stuck in AWS's walled garden, if you're cost bound, if you want to avoid managing infrastructure, that's probably the most important one. And if you have a reasonably simple data set, then if you satisfy all of those things, then it's a pretty good choice. If you don't satisfy all of those things, maybe not. But it is nice that it's so stable. The API, it's stable, but the API sucks, to be clear, but it is stable, it is stably sucky. But projects I wrote like 8+ years ago, I can still go visit them again. They're still running in AWS's free tier. I can still go visit them again. They still run on demand and they just work. And that is satisfying when that happens over the course of a decade. It's just can be a little bit important to do a little bit of due diligence depending on your usage. But in general, I actually would recommend working with this approach, and I'm sure a lot of people do. Particularly with hobby projects, the result is, for me at least, the result is more important than the process, depending on the project I'm doing. And being naive and learning the hard way is often a lot more likely to get results than if you were to do all of your due diligence for every single piece of technology that you were going to do, that you're going to use ahead of time. So you might lose $30 or $40 like I did, not a whole lot. Hopefully you won't lose $100,000, but trust your developer instincts. Usually, if you're doing something that loses $100,000, you're probably going to have a feeling that you're doing something weird. Either that or you've just left a video open on S3. Same thing. Yeah, that's it. Yeah, any questions? Can't do it right.
I noticed that you're doing a lot of optimization for not all that many cents. And that's what kind of struck me. If you spend your time saying PostgreSQL, it takes quite a bit of time. DynamoDb is a bit shorter. So have you computed how much you sort of benefited from using Dynamo instead of Postgres sort of in time?
Well, I mean, if I ran a Postgres, I'd have to run it on an instance.
Yeah, no, I was actually thinking about the time it actually takes to pronounce those two words.
Oh!
Yeah,
Good point!
Yeah.
DynamoDB. We need to find a... Can we say DynamoDb?
Yeah, that's right.
DynamoDb.
DynamoDb.
DynamoDb. Sorry, that was Danish. Yeah, anyone else?
How many, now that you have scaled up from like 5 friends, how much usage is your thing tolerating now?
From 5 friends. Yeah, no, it is. I haven't actually checked how many rows there are in that. I should do that sometime. I should have done that before this. I would say there's probably over. There must be over 1 million check-ins stored in that row. But it is with all of the beer festivals. It is 2,000 to 3,000 users, and those users are persistent. So once a user gets added to that service, their check-ins are being polled every half hour. I forgot to mention that because it was so cheap, doing it the right way, I ramped up a little bit of the usage. So it checks every half hour the new check-ins, and when the app is active, when you're using the app, it's polling the service pretty frequently to check if you've checked in any new beers. Especially because if you're at the beer festival and there's multiple sessions, a lot of people can go out between the sessions, drink beers at a bar, and then they won't check those beers in on the app, so they would like to have that star just appear because they drunk it on Untapped. And that's now possible because it was cheap. Yeah. Oh.
Yeah, so if Amazon had updated their documentation and added a big warning sign next to the scan function, scan command, and next to the filter property of the queries, would that have saved you?
Maybe.
But why Amazon would do that?
Exactly, it's a big cash cow.
Yeah.
They have entire jobs that are dedicated that can't find pricing.
You know, for me personally, the thing that would have, if I had gotten that image in my head, I know I have used Redis repeatedly for a lot of different projects over the years, and if I had gotten that image in my head when I first went to DynamoDB that this is a database in the same class as Redis, then I would have understood that it is incredibly expensive to try and find to scan through the entire database to find a single row. But yeah, if you also had that on the it's the abstraction of read request units. It's so obscure. You have to actually go in and understand what exactly that means and how what you're doing applies to their billing thing. It's not. There's no direct that request cost you $15?
Well, you can add a parameter and in get read request units you consume the
Yeah, it does say that back. But again, that's one step removed from you just spent this amount of cash.
Right.
Yeah. Yeah. I don't think that was unintentional.
No.
All right.